This lesson is on chapter 2-7, titled Solving Equations with Rational Numbers. I'm going to go right into solving examples here, but what I always want you to think about is getting the variable by itself and always doing the opposite operation in order to solve for that unknown variable. So the first example says x, so some number minus 2 and 73/100 equals 1 and 31/100. Okay, so again, I'm going to think of the opposite operation. I'm going to think of the opposite of subtraction is addition, because I have to get my x by itself. I have to get rid of that negative or that minus 2 and 73/100. So I'm going to add, do the opposite, 2 and 73/100 to both sides. And please get in the habit of showing your work like this, like we talked about in kind of when going over the 6th grade chapters. This crosses out. I'm going to bring down my x. So then all I'm going to add, so 3 plus 1 is 4, 7 plus 3 is 10, carry the 1, 2 plus 1 is 3, plus 1 is 4. So x is 4 and 4/100. Again, and I want you to go back and double check your work. I want you to plug this, your answer, into for your variable and say just 4 and 4/100 minus 2 and 73/100. Does that equal 1 and 31/100? Again, you can go back and subtract. Borrow. Then we get 1. So that checks out. So there's 4 and 4/100 is my final answer. Please don't forget to check your work. Secondly, we have another equation, 4/5 times y equals 2/3. So again, I have to get my y by itself, so I have to remove that 4/5. In order to remove that 4/5, we can just multiply it by its reciprocal. So I'm going to times 4/5, I'm sorry, I did that wrong. I'm going to times this by 5/4, because if you think about this, 5 times 4 is 20. 4 times 5 is 20, so 20 over 20y is the same as 1. So that cancels out into 1y. So again, we're just multiplying it by its reciprocal. Again, in order to get that y by itself. So we're going to get 1y is going to equal 2 times 5 is 10, 3 times 4 is 12. So my answer is 1y, or just y, is going to equal 10/12. Again, let's go back and check. So does 4/5 times 10/12, is that going to equal 2/3? All right, so let's see, 4 times 10 is 40, 5 times 12 is 60. Does that equal 2/3? Well, I know I can cross off my zeros. And does 4/6 equal 2/3? It sure does, because this looks a little messy. 4/5 reduces to 2/3. All you have to do is divide by 2 on both of those. Okay, so we know 4/6 is 2/3. I know this probably looks a little confusing. So I know that's my answer. So I know 10/12 is my answer. Again, when you're given a problem like this, in order to get rid of our fraction next to the variable, all we have to do is multiply it by its reciprocal or its multiplicative inverse in order to get that 1y. Next, I have negative 2/3 plus our variable f equals 3/5. Again, I got to get the f by itself, so I have to remove that negative 2/3. So the opposite of negative 2/3 is positive 2/3. So I'm going to add 2/3 to this side. I'm going to add 2/3 to this side of the equation. So this is going to cross off to make my 0. I'm going to bring down my f. So we have 3/5 plus 2/3. Let's make common denominators of 15. So 5 times 3 is 15, so 3 times 3 is 9. 3 times 5 is 15, so 2 times 5 is 10. So 9/15 plus 10/15 is going to give us, and I'm just going to actually write this over here, 19/15. And that's going to reduce to 1 and 4/15. So that's my final answer. Again, please plug this back into your original to check. For the sake of time in this video, I'm not going to go back and check my work, but please make sure as you're doing the problems, go back and check to make sure you got the final answer correct. Again, in this example, we just added the opposite operation in order to get rid of my fraction here. and then whatever you do to one side of the equal sign, you have to do to the other. My next example says 3/5 times x, or times something, is going to equal 6. Okay, so just kind of like we did in, let's see, this example right here with the multiplicative inverse or the reciprocal, we're going to do the exact same thing. In order to cancel out the 3/5, we're going to multiply by 5/3, because this will cancel out to make 1 5/3. So I'm left with x is going to equal 6 times 5/3. Please remember, put a 1 underneath the 6 so you know how to multiply correctly. 6 times 5 is 30. 1 times 3 is 3. And I know 30 divided by 3 equals 10. So I know x is going to equal 10. Go back and check. Does 3/5 times 10 equal 6? Again, you're plugging this back into here. Well, I know 30 divided by 5, does that equal 6? Because again, I'm just multiplying across. You can put a 1 underneath. 30 divided by 5 does equal 6, so 6 equals 6, so it checks out. So my answer remains as 10. Do I have any more examples? Yes, it looks like I have one last one, and then we'll be done. So I have some number divided by 2.5 is going to equal 4 2/10. Okay, so we can think there's an imaginary 1 right here. Okay, so whenever you have that variable by itself, think of the 1 in front. Again, let's do the same thing. Let's multiply it by the reciprocal, times this by 2.5 over 1, and that's going to cancel this side out. Multiply this by 2.5 over 1, which is this. We can actually get rid of this. All we have to do is find our answer of 4 2/10 times 2 5/10, and that's going to equal 10.5, or 10 5/10. Again, plug this back in. So you have 10.5 divided by 2.5, and that's going to equal 4 2/10, so that checks out. So thank you for watching this video. Again, think opposite operation. Think of getting that variable by itself, and please showing your work correctly and checking it at the end. This is, again, a review of what we did in 6th grade math, so hopefully this is pretty easy for you to work on now. Thanks for watching.